Hello again. I am giving you one of the videos that I promised you that is going to be posted tonight. It is about numerical expressions. You're going to be starting on that subject tomorrow. 9.1 is going to be posted tomorrow for you guys to be working on. It's actually, you can access it already on the math website. However, I did not have it come up for assignment until Wednesday. So you'll see it. And it's a new thing for us. We've been working on fractions and fraction derivatives for a long time. So fractions, ratios, um, percentages, all those are based in fractions. So now we're going to put all of that aside and move on to number expressions, which is actually the first step in getting into algebra, which is really kind of the fun stuff of math. And this is some of my favorite stuff. So I'm really excited about it. And yeah, maybe I can hopefully generate some excitement in you guys. I don't know. I know you guys hate math, but there's nothing to hate here. It's all fun. Okay, so excuse me. So onward. I'm going to start with some vocabulary that you guys are going to need to know. First, in math, an expression that is a mathematical phrase that contains numbers. So mathematical phrase that contains numbers. Okay, good. The next one is variables. Variables are letters or symbols that are used in place of a quantity that we don't know yet. So used in place, used in place of an unknown quantity. So when we were doing quantity, so when we were doing percentages, and I had done that video on percentages. Feel free to write this down if you can understand it. Just leave it there if you don't. And we were doing how to find the certain part of the percentage. We used x. That is the most common variable when you try to find the value of x, or you just x is the most common unknown quantity. But as you get older, as you get into more complicated mathematics like calculus and so forth, you're going to use, and especially if you carry that into like the sciences and so forth, you're going to use more of the Greek letters. So one that you're going to be using a lot is pi. That's right there. That is pi equals pi. There is also one that has to, well, there's several of them. So several Greek letters that you're going to be using that will help you to understand what it is that you're trying to figure out. So you need to know that the most common, and when you get into 7th grade, you're going to find out this stuff a lot when you're doing linear equations. You're going to have to find out x and find out y. I don't know why, just because. So those are probably some of your two most commonly used variables. So examples would be x plus 5 or 3m minus 2. These are all numerical expressions using variables. A over B. Okay? Also, they don't have to have a variable. So you could have 59 plus -3. That is also a numerical expression. 44K. Now, one thing about this right here that you need to understand is that anything directly in front of or in back of a parentheses a bracket or a variable is automatically multiplied. So when you have 44K, whenever you find out what the value of K is, you know that you're going to multiply it by 44. You always know that 44K means 44 times K. And from now on, we're going to use that dot for multiplication because we don't want it to get confused with X, which is now a variable. Okay. All right. So sometimes we use an expression that allows us to do calculations to find out what quantity the variable is. Frequently, we will do this in the form of a word problem. So for an example, when Georgia runs, she runs a 6-mile loop each day. We don't know how many days she runs, so we'll call that number D, which is number of days. So now we can say that Georgia runs 6D. Wow, my dyslexia just came out. 6D. So that's saying 6 times she runs 6 loops every day. And when we find out how many days she runs, we'll know how many loops because we're going to multiply that by 6. Okay, so that's the expression that represents how much Georgia runs each week. When a number is attached to a variable, like 60, you multiply that number and the variable. Any number that is used to multiply a variable, in this case 6, is called a coefficient. So anything that is used, any number that's used to multiply a variable is a coefficient. So that's 6. So in the case of 44K, the coefficient was 44. Okay. So far we have done expression, which is a mathematical phrase, a variable, which is letters or symbols used in place of a quantity we don't know yet, and coefficient, any number that is attached to the variable. And a constant is a number that stays fixed in an expression. For instance, in the expression 6x divided by 4, this is the coefficient, this is the variable, and this, which is not dependent on anything else around it, it stays constant. It will stay 4. That is the constant. So the expression is made up of one or more terms, which is a number by itself or the product of a number and variable, or more than one variable. Each term is separated by an additional calculation symbol. So this is a term. This also is a term. So it's a part of an expression that is separated by a directive symbol. So Hold on a second. I guess this was supposed to actually be a plus, but it's still the same thing. So if you were to have 5x plus 3y times 7x squared y, this would be a numerical expression. These would each be terms in the numerical expressions. This would be the coefficient. This would be the variable. We don't have a constant in here. And this little doohickey is actually called the exponent. And we'll be learning about exponents in this thing as well. An exponent is telling you that how many times you're going to be multiplying the term times itself. So 7 times x times y, because we're multiplying x times itself 2 times. Okay. Onward. Okay. So, in the term 3y, or the numerical expression 3y, we know that this is the coefficient and this is the variable. In the term 5x plus y, or plus, I'm sorry, 11, again, coefficient, variable, and constant. Okay. All right. So let's move on a little bit. Now we're going to talk a little bit about properties. Properties are a set of math rules that are always true. Kind of like in a fraction, if you do it on one side, if you do it on the top, you have to do it on the bottom. That is a property of the math, of that particular form of math. Set of math rules. Always true. Yes. Huh? Thank you. Okay, so an important property is identity property of addition. Identity property of addition. And it looks like this. A plus 0, that through there so you know it's a 0, not an O, equals A. It says that if you add 0 to any number, that number stays the same. Seems like you shouldn't have to state that, but you do. It's true. So that value plus 0 is always going to be the same value. The identity property of multiplication, however, is along the same lines, but it looks different. 7 times 1 equals 7. Anytime you multiply a number times 1, it will still remain that number. So if you multiply any number by 1, that number stays the same. That's the identity property of multiplication. Now, we're going to look at the commutative property of addition. Which looks like this. A plus B equals or is the same as B plus A. It says that when adding 2 or more numbers, you can add them in any order and it will be the same. So, for instance, you can add 5 plus 7 and that equals 12. You can also add 7 plus 5 and that will also equal 12. That's the commutative property of addition. Okay, and now we're going to look at the commutative property of multiplication. And it looks like this. A times B is the same as B times A. It can also be written as AB equals BA. You don't necessarily have to have that, especially when you're doing variables. But it says when multiplying 2 or more numbers, you can multiply them in any order and the answer will be the same. So, sticking with our 5 times 7, or 5 and 7 theme, 5 times 7 is 35, and 7 times 5 equals 35. Okay? Now, an important thing to remember, the commutative properties, both of addition and multiplication, only work with addition and multiplication. Okay? So you can't say that 5 minus 7 is the same as 7 minus 5. 7 minus 5 is 2. 5 minus 7 is negative 2. Okay? 5 divided by 7 is something that is different than 7 divided by 5. Okay. When talking about properties, we would probably use the term equivalent expressions, which simply means that the math sentences have equal value. So 3 plus 11 equals 11 plus 3. That means these expressions are equivalent. They are not the same, but they are equal. Okay? Now, we're going to move on to the associative property of addition. And I don't want you to worry about writing all this down because I'm going to put it into a sheet. And what I'm going to do for those of you that are coming back for BPE, to BPE for 7th grade, I'm going to make sure that you have those blue books, all of you, even if they've gotten lost in the shuffle. And I'm going to make sure they're going to get added to, because this all needs to go into your blue book. Because I'm going to be teaching 8th grade and I want my students to have those very same blue books. Spell that. Associative, there we go. property of addition. This looks like this. A plus B plus C equals A plus B plus C. It says that when adding three different numbers, you can change the order that you add them by moving the parentheses, and the answer will still be the same. Now I want you to remember, as we're doing this, this is part of getting to learn the rules of PEMDAS, of the order of operations. You have to know these properties in order to make sure that you are always doing the order of operations correctly. It's all good and fine to memorize parentheses, exponents. Let me see, PEMDAS B. Let me write it down. Okay, parentheses, exponents, multiplication, division, addition, subtraction. Okay, so this right here is reinforced by all these properties, all these rules, set of math rules that are always true. Okay, PEMDAS is a good thing to remember when you're doing multiple combinations of algebraic problems, but you kind of have to know why, and this is the why, because it's a law of math. Okay, so this one, the associative property of addition, says that when you are adding three different numbers, you can change the order that you add them by moving the parentheses, and the answer will still be the same. And that's true. So this is associative property of addition. And then, of course, you're going to say, of course, there is an associative property of multiplication. Okay, and that says basically the same thing, only subtract, add in, substitute multiplication. So it's saying that when multiplying three different numbers, you can change the order that you multiply by moving the parentheses, and the answer will still be the same. So if you were to put this together, 2 times 5 is 10, times 8, that's 80. And then you do this over here, 5 times 8 is 40, times 2, that's 80. You multiplied them in different orders because you followed PEMDAS and did the parentheses first, but they turned out to be the same. They're not the same, they're equal. Yeah. And again, don't forget, the associative properties only work with addition and multiplication. They do not work with subtraction and division. Okay? Now we're going to talk about the distributive property of multiplication over addition. And this is where things start to get really, really fun. I know fun is a relative term for you guys, but for me it's fun because I love it. This is my favorite math in all the world. Okay, so this is distributive property of multiplication over, I'm going to put over this way, over addition. So that looks like a, remember, anything directly in front of a parentheses or in back of a parentheses is automatically multiplied. So I don't have to make a multiplication sign here, and you will automatically know that means multiplication. A parentheses B plus C is the same as, and this is where it gets tricky, A B plus A C. It says that adding two numbers inside parentheses and multiplying that sum by a number outside the parentheses is equal to first multiplying the number outside the parentheses by each of the numbers inside the parentheses and then adding the two products together. That's gobbledygook. But basically what it's saying is that this right here is the same as this right here. And the way we do that is we distribute the problems out. So you're going to take what's outside the parentheses and multiply it times what's inside the parentheses. But you have to do it one term at a time. So you have to go A times B, and then you have an addition, and then you do A times C. Okay? So that's how you turn out with A, B, which means A times B. And because this is a plus sign there, it's going to be plus A times C, or AC. Okay? That's called distributing it out. Okay, so it allows us to simplify an expression by taking out the parentheses. Okay? So, as a numerical example, we're going to say 2 times, because again, what's directly in front of the parentheses is automatically multiplied, 4 plus 6, close parentheses. And that's going to be equal to 2 times 4 plus 2 times 6. And the way that's going to work, and I want to first work this out, 4 plus 6 is what? It's 10. And you're going to multiply that by 2. So that equals 20. Or if you do this, where you do 10 times 4, or 2 times 4, that's 8, plus 2 times 6, which is 12, and add it together, that is going to be 20. Okay, so you can work it out either way, but if you're wanting to simplify it, you've got to have to get rid of those parentheses by distributing out the math. So you distribute the 2 across the terms inside the parentheses. Both expressions will equal 20, as we found out. So now we're going to show what it looks like when there is a variable inside the parentheses. So you have 7 times x plus 8. Now we can't solve that because this is unknown. But what we can do is simplify it by making 7 times x and then adding it to 7 times 8. So here we have 7x from that first one plus 7 times 8 is 56. And we could solve that out. Not going to do that right now, but we could. So that is the distributive property of multiplication over addition. Now, the same thing is actually true with subtraction. So let's say we have 9 times 5 minus 3. Okay. If we were just to work this out, it would be 5 minus 3, which is 2, times 9, which is 18. So we'll put that up here just as a reference. But what we're going to do is we're going to work it out. We're going to go 9 times 5, which is 45. And then 9 times 3, which is 27. But our sign right here is going to be minus. So 27. So let's see if that checks out. 45 minus 27. We're going to borrow from the 4 and give it to the 5 here, making that 15 minus 7, which is 8. 4 minus 2. Uh-oh. No, we carried that over. That should have been a 3. 3 minus 2 is 1. So it's 18. So it stays the same. Equal, not the same. And then if we're dealing with variables inside the parentheses, it's going to be the same as it was with the addition. So let's say we have 6 times x minus 8. We're going to do this 6 times that, and then over here 6 times that, with the minus in between, with the subtraction in between. So 6 times x is 6x. Minus 6 times 8 is 48. Okay? Now, the reason we do that is because I can tell you right now, by looking at this, you wouldn't be able to really figure out what that x is. You wouldn't be able to work that problem out. But if you go ahead and multiply it out, you distribute it, then you can work that out. Because right here, we know that this is multiplication, right? So the way to isolate the x would be to divide it out with a fraction. Put 6 under here. Whatever we do on one side, we have to do on the other. Well, hold on. Well, actually, this isn't an equality, so I'm not going to be able to work that out. So never you mind. We'll work it out later. I'll show you what I mean later when we're doing equalities. Okay. So we've done distributive property, we've done associative property, all kinds of stuff so far. And now what we're going to do is factoring. Factoring is fun. Remember that a factor is one of one or more numbers that is involved in a multiplication problem. So it's the reverse of distributive property. Instead of getting rid of parentheses, factoring allows us to include parentheses because sometimes it's simpler to work with an expression that has parentheses. So if we have an expression that goes like this, 15y plus 12, we want to factor it out. So we ask ourselves, what is the greatest common factor of both of these terms? The GCF of both of these terms, 15 and 12. That would be 3. So what we're going to do is we're going to pull that 3 out of both of these terms. Okay, so so what we're going to do is we're going to stick a 3 out here. You can do it any number of ways. You can divide it out using a fraction, and that's probably one of the easiest ways, knowing that you're going to put this 3 out here on the outside of the parentheses. 3 goes into 15 how many times? 5, and that y has to stay there, and it's plus, so we're going to put that, and 3 goes into 12 how many times? 4 times. So that's the same thing. This is what you would get if you were to go ahead and multiply this out. It's the opposite of the distributive power property. So basically you take this and you divide out the greatest common factor, and you have a less bulky problem. So you can always check your answer by using a distributive property. As I said, you can multiply it back out and see if you get this again, and that would be correct. So another one, let's just, as by means of practice, we're going to do 12a plus 18. Okay, so we're going to look at that and say, what is the GCF? the greatest common factor of both 12 and 18. And if you're thinking hard, you know that that is going to be 6. So we're going to pull this right here with a 6. And we're going to put a 6 right there. 6 goes into 12 how many times? It would be 2. We're going to carry down the variable. Add. 6 goes into 18 3 times. And pull that there. Close the parentheses. All right. I know this is a lot of information, but I want you to be able to use it and use it well. Okay, so we collect like terms. It's also called combining like terms. Let me do this real quick. So sometimes you're going to get a problem that looks like maybe like this. 9x minus 3x plus 5x equals 11x. Okay. Well, if you look, each one of these just has the one variable, and it's just x. There's no exponents or anything else, just x. So combining the like terms means putting all these ones that are exactly the same together. Now, if this was a y right here, we couldn't combine this with anything because there are no other y's. We would only be able to do these two. But because this is an x, we can combine the whole thing. Okay, so we're going to put these together, and just simply by doing the math. You're going to say 9x minus 3x. So you take your coefficient and subtract the coefficient from here, and the variables stay the same. So 9x minus 3x is going to be 6x. And then 6x plus 5x equals 11x. And we're going to combine these two, 11x, because 6 plus 5 is 11, and the variable stays the same. And of course, 11x absolutely does equal 11x. Okay. Now, if you were to have a problem that looks like this, 7m plus 3y minus 2m plus y plus 8. Well, for one thing, what you need to understand is that because of the fact that we are doing all these with like terms, it's very difficult for us to say minus this term, because this is 7m plus. So where does that plus go? Does it refer to this or does it refer to this? So from now on, we're not going to be saying minus 2m. We're going to say plus negative 2m. So 7m plus 3y plus negative 2m plus y plus 8. Remember we talked about that, I think, in the beginning of the year. When you're doing algebra, we don't really talk about subtracting. We talk about adding negative numbers. It just makes it less confusing when we're trying to do what we're doing here, which is combining like terms. So everything is addition. This is 3m plus y, 3y plus negative m, negative 2m, plus y, plus 8. Now, when we're looking at our terms, we can see that there's one here that is an m, and one here that is an M. And we can combine those together. We have one here that is a Y and one here that is a Y. Now, incidentally, it just says Y. The 1 is implied because anything times 1 is itself. So this is the same thing as 1Y. But that is, like I said, implied. It's an invisible 1. And then we have this one by itself over here. That's a constant, remember? Okay, so when we're combining our like terms, we're going to get these two together. 7 plus negative 2m. 7m plus negative 2m will add up to be 5m. And then we know that this is going to be plus 3y plus y, or 1y, is going to be 4y. And then this little guy over here by himself is going to be 8. So when we have combined all of the like terms, this is what we get. Okay? I need you guys to remember this, that we are not going to be subtracting like terms. We're going to be adding negative terms. It's a matter of semantics when you come down to it, but it makes it a lot less confusing in the end. So remember that a term with a variable cannot be combined with a coefficient or a constant. 3ab can combine with 4ab or ba because the commutative property of multiplication tells us that ab and ba are equivalent. Okay, but when you're doing your variables, you should make every effort to get them into alphabetical order. So 4ab can be added to 3ba because of our commutative property says that AB and BA are the same thing. So when you're adding them to the same, it would be 7. And because we're going to put things in alphabetical order, we're going to say AB. Okay? Wasn't this fun? I'm having a great time. Okay, one more thing that we have to talk about, and that is exponents. And you know what? We've been doing this for a while, so I think I'm going to give us a break, and I'm going to post the exponents video on Wednesday, because we have learned an awful lot. I'm going to get all this stuff down into an anchor chart for you guys, and I will post it for you. Because like I said, it's a lot. Okay. Well, thank you for watching, and I hope it helps. And if you need anything, you know how to get in touch with me. All right, guys.